In this example problem, we have 4 separate questions that are going to allow us to mess around with probability in a different way to find the chance that a certain outcome happens. In the first question, we have that Apple has become a household name in America. And a store owner is estimating that the likelihood of owning an Apple product is 61% with a household with kids and 48% for households without kids. So having kids will have a positive effect on Apple ownership. As a parent myself, I can definitely see how that's a possibility. We're going to suppose that there are 1,200 households in the community around where this store operates, of which 820 have kids and the remainder do not. Well, the first thing we're asked to find is what are the probability that any one random household will have kids? Well, to do that, we can just take the number that meets that criteria and divide it by the total sample size. So we're told here that 820 households have kids out of the 1,200 in the area, and that's 68.33%, if you will, of the households in this community around this store that have kids. What about the houses that don't have kids? Well, this has to be a complementary probability. Like those two have to be mutually exhaustive. You either have kids or you don't have kids, which means I can figure that out by just hitting 1 minus the probability that a household has kids. And it makes sense. If 68.33% of households have kids, the other 31.67 will not. Next, we're asked to find what is the probability that household is with kids and owns an Apple product. But we just determined the first portion of that. This is the probability that a household will have kids. And our information provided tells us that we can expect that 61% of households with kids will be Apple users, will have Apple products. So I can just multiply those two together to find the probability of both instances happening. It's a joint probability. So I'm going to take the 68.33% of households in our demographic that have children and multiply it by the 61% chance, or 0.61, that a household with kids will be and will contain Apple products. And if I do that, I come up with 0.4168. So it's 41.68% of the households in this area have kids and will use Apple. What about the probability that a household is without kids and does not, the most important part, own an Apple product? Well, we have the probability right here that there's a household of a household not having kids in our area, but we don't have the probability they don't own an Apple product. But we have the complement of that. We have the probability that a house without kids will have an Apple product, 48%. So 48% of kidless households, if you will, don't have an Apple product. The complement of that, which is 52%, are going to not have an Apple product. So let me just multiply that out really fast. 3167 is the probability of a household not having kids times 1 minus the probability that there is kids in the area, and it's 0.48. And that comes out to 16.47, which is our answer right here. 0.164, I'm going to round off 7. There's different ways that we can get around to that too. Instead of taking the 1 minus at the end, I could have just said that it's equal to cell B4 times 0.52, because I know that's the probability here that a house without kids is not going to be Apple users. I could have said, okay, let me figure out what the probability is that a house without kids is an Apple user here. So I could have said 31.67 times the 0.48. That would have given me 0.152. Let's add not decimal to that, 0. And then I could have simply subtracted that from the probability of all households not having kids, and it all come out to the same number. So there's multiple ways to get there, but it's just looking at the information that's provided and working with it using joint probability rules and complement rules to figure out which is the probability, what is the probability of our certain conditions being met. On to question 2. Surgery for a painful common back condition often results in significantly reduced back pain and better physical function than treatment with drugs and physical therapy. We have a researcher who's looked at 803 patients. That's our sample size. And out of those 803 patients that were followed, 398 had surgery. And after 2 years, of those that had surgery, 63% of this 398 said that they had major improvements in their condition. People who elected not to have surgery, who went about it with drugs and PT, if you will, only had a 29% rate of major improvement. So let's figure out what the probabilities of these certain areas are. And we can start just like we did on the last one. What's the probability that a patient had surgery? We'll take the number of people that meet that condition, 398, and divide by the total sample size, which is 803. And we're going to come up with 0.4956. So 49.56% of our observed patients in this sample ended up having surgery. What's the probability that any one given patient in this case did not have surgery? It's another complement function. If we know that everybody either had surgery or didn't have surgery, and we know this is the percentage of people that had surgery, 1 minus that has to be the percentage or probability of people that did not have surgery, 0.5044. We're asked to find, next up, what is the probability that the patient both had surgery and saw major improvements? Well, that's a joint probability, two of them together. So we can go and we can take the probability that somebody had surgery, 0.4956, and multiply it by the probability that someone who would have surgery would show major improvement, which is 63%. And that comes out to 31.23. So 31.23% of our sample is people that had surgery and experienced major improvement because of it. And going forward, when we're pitching the product, I mean, that's the percent of our overall population we could expect to meet this criteria during an upcoming period. Last one we have is what is the probability the patient received non-surgical treatment and had major improvements? Well, what percent of people in this case would have had non-surgical treatment? We've got that, 0.5044. And of that grouping, only 29% showed that they had a major improvement in their condition. So I don't need to mess around like I did up here because I have the exact number that I'm looking for. I can just multiply that 5044 in cell B10 times the expected percentage of major improvement, which was 29% for people who had the non-surgical treatment. And that comes out to 0.1467. So we've got a breakdown of certain expected outcomes over here in this case. And if you're working at a hospital and you're trying to pitch best treatment to somebody, obviously we have enough information here to say that, yeah, surgery is probably the better route to go instead of drugs and PT.